concerned. Because I believe they gave you this side, this one, these two. The tick marks might be off. One might have been 1 and 2, but it was basically something like that. And then they gave you all of that info. Now, in order for us to be able to tell whether or not that you have something that is going to be like triangles that are going to be congruent, that means that you have to have a correspondence between all 6 pieces. All 3 angles have to match up. All 3 sides have to match up. As of right now, bless you, according to the diagram, we only have 2 of each. Okay? We're short an angle and we're short a side. The angle is the easy one to find because we talked about how that worked. Remember, whenever you have a triangle, you have how many degrees? 180. If 2 of the angles in one triangle are the same as 2 of the angles in the other triangle, what has to happen with the third angle? Yeah, the last angles have to be equal as well. So right away, we could have just drawn the diagram and marked this up and said that those 2 have to be congruent because I think the theorem was called what, the third angle theorem? Does that sound right? Something like that. Now you have 3 angles and 2 sides, but you didn't know what to do about that third side. And that was my fault. I forgot that this problem looked like that because there's something we should define. I'll show you. So get your progression sheet out. I want to make sure I throw this thing in there. When we did our progression sheets last week, I think the first couple of things that we had put on there were some of the look for this. Remember how we said look for vertical angles? Do an example of what it looked like. We said it's like a bow tie problem and so on. Wow, what do you love? You recognize your name on that? So what I want to do here is, this is another one of those things that we look for, something that we can infer from a diagram. So put an asterisk in one of the boxes, and then I'm going to put in here, look for a shared side. Okay, we're going to look for a shared side. And before I get too far into the definition of this, it kind of works like this. If I take a piece of paper, cut it in half, fold it in half. You could, anyway, you guys agree that that's a triangle? Okay. You agree that this is the same triangle? Okay. So the triangle here is the same as the triangle there. There and here, here and there. Not on a boat. Not on with a goat. Anyway, but if I pull these apart, do I still have 2 triangles? Do they have something in common? The pole, right? So if you think about what's going on here, when you have this shared side between 2 triangles, you're dealing with a property in math known as the reflexive property. And I'll explain a little bit more about that here in a second. But if this side is shared between 2 triangles that already have all the other parts that are the same, that makes this side for both of these the same, doesn't it? It makes it that full piece. It just happens to be an overlap thing, if you will. All right. So what happens here is we use this thing called the property. This property called reflexive. So what I do is I draw a little example of a triangle with a side in between. You guys have all seen diagrams like that before. We've done this one pretty regularly. And what I do is I just kind of label it with generic letters. I'm just going to go A, B, C, and D. If I label it like that, what segment is shared between both triangles? BD. I can say BD or DB, it doesn't matter. It's still the same exact thing. Okay? So in a proof, sometimes you have to show that something is congruent to itself. So before I do this, do you guys agree with this statement? The number 3 equals the number 3. Okay. If I say that it is 3 feet is equal to 3 feet. Now, if I'm talking about a segment that's 3 feet long, and the other segment is 3 feet long, now that this something has measurement, when something has a physical measurement to it, I no longer say that it's equal. I can say that it is congruent. So what happens is, once we start talking about things with segments that are equal in measure, segments that are the same, I can say that BD is congruent to itself because of what's called the reflexive property. There's a reason why we need to use this, and it's going to show up when we start talking more and more about congruent triangles, what we call the alphabet soup. Side, 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 side angle, side, and so on and so on. And so on. But we all know that there is no. We missed you on Tuesday because we threw that one out there for you. Okay. So this is one of those things that does show up. So like we've said before, there are certain things you can infer from a diagram. We talked a lot about this. We can say that we have vertical angles that are congruent. I have a shared side. I can put this as a tick mark to say that it is congruent to itself. I can look at a diagram and tell whether or not something creates a linear pair. I can look at a diagram and see if something is perpendicular. I can say that they form right angles. I can look at a diagram and tell whether or not something's been bisected. If, for example, this has nothing to do with this problem, but if that shows up in a problem, less the stuff above it, what can I say about point D? What can I say about point D there if I mark up AD and DC like that? It's the midpoint. I can say that because D is halfway between, because the two segments that it connects are equal to each other. It's that little bit of information that we've been doing with diagrams called inference. We've been taking information and using it. Right? So this is what we're going to be using. In order for number 30 to work, you had, one direction, you had to put this in. Then you have now all 3 parts that are equal and all 3 parts that are congruent because you had to put in the third angles. And then that side that's shared is what's called reflexive. That's where that comes from. Okay? That's what that would look like. And eventually, when we do regular triangle proofs, this will be very, very, very simple to look at. Right? Yes. Okay. I just forgot to tell you this thing called the reflexive property. You know, it was the Monday, it was a Friday, all on a Tuesday. But does that make sense about how that works? Okay, that's what we call a reflexive property. Eventually, we might have that same exact thing in terms of angles. We'll have angles that are shared between 2 triangles because of what's called overlapping. There's certain things like that that'll occur. It's nothing too crazy. It happens more with angles when we talk about similarity, but for right now, we're just looking at it with the shared side. Okay? That's why I say in your progression sheet, we have look for a shared side. We're good to go. Okay? Not a big deal? You were also saying about number 8, I think? Okay. On number 8, yeah, people were asking about this one earlier. Number 8 actually uses the diagram I just drew. Number 8 used that diagram. Number 8 said that it was A, B, you went the right way, A, B, C, and D. Number 8 was just using the diagram on the left versus the one on the right. In the book, it says, what are the two, it says, I think, ABC and ABD, what are all the parts? So it says that if triangle ABC triangle ABC is congruent to triangle ABD, what are all the congruent parts? Well, I would have to go through and list them all. I know that I can't say angle A here. I'd have to say angle CAB, DAB, angle C, angle D, ABC, ABD. I'm doing things like that. What parts are all matching up? All those are my 3 angles. AC, AD, CB, BB, then AB, and AB. That's all you had to do. But you wrote it out in terms of letters. That's all that meant. Right? That's all it meant. It's meant right after the letters. The same thing on the other construction trestle. Yeah, that's really about all we did with 4.1, was just labeling and looking for some very simple algorithms. Were there any others on there? What one do you guys have? What was what? Yeah, on the first one's here, you're saying no, it's just what is the equal. Yeah, we're not worried about groups at all. You were saying 4? So in 4 it says in triangle map and triangle tie, A is congruent to I, and so on and so on and so on. Okay. So they're saying that you have triangle MAP is congruent to triangle TIE. And then it tells you A is congruent to I. And then it said that angle P is congruent to E. What's the relationship between angles M and T? They're congruent. So that means then angle M has to be congruent to angle T. That's the lettering match up. And the last part says if angle A is 52, this is where drawing a picture comes into play. M, A, P, T, I, E. It says M is 52. And P is 36. What is the measure of angle T? What does it have to be? 52. Follow the letters. They gave you more information there than you needed to know. Okay? Because when you go through your lettering here, M and T have to match. So this has to be 52. P and E have to match. It has to be 36. Add those two together, you got 88, which meant that A and I are both 92. So that's why when you draw it out, you can fill in the blanks because you know where the correspondence occurs. That's the trick. Okay, that's the trick. Okay. Any others? All right, let's talk about our quiz for manana. So tomorrow we have a quiz, and it seems like there's a lot of material, but there really isn't. It's if you want to go back into the sections that we did, and we obviously didn't do all of these sections. We did parts of each section. We did 2.1, 2, 4, and I'm going to go kind of section by section of what pieces we did, so we know what sections to revisit. Yes, sir.
We're getting like a worksheet or.
I have some problems for us to look at here in a little bit. Okay. From talking with the other classes earlier today, when going through these sections here, most people are just flying right through it. They're like, "Oh yeah, I remember that. Oh yeah, I remember that." You know, there hasn't been much of a hiccup, if you will. So this should be fairly straightforward. In section 2.1, that was the day that I had you guys watch the video that didn't really work, I guess. But it all was about like number patterns, and then it was about what were called counterexamples. Now, I'm not going to really worry so much about number patterns, like find the next 3 numbers in the sequence, but I do want to make sure we understand what was meant by the idea of what was called a counterexample. So let's talk about it. What was a counterexample? Yeah, I don't know if you guys heard her. She said that a counterexample is any statement that disproves something. Okay. Counterexample is any statement that disproves. Okay. Any statement that disproves something, and look at a really good one. Let's back up here. Here's the statement. I want you to come up with a counterexample. I don't know if I spelled poisonous right. Garter snakes, corn snake, yeah. If I say that all snakes are poisonous, you'd say, no, Murphy, you're not right. You're wrong, because here's my counterexample. Garter snake. Corn snake. I totally forgot about that one. Okay, things like that. It's just a quick little counterexample. Anything you can come up with to disprove something. Fun story. My father-in-law is horribly afraid of snakes, like just scares the bejesus out of us, you would say. And so my oldest son, Connor, he idolizes Grandpa to the nth degree. You know, Grandpa is just, so far beyond Mom and Dad. He's just like Grandpa's everything to him. So of course now Connor is afraid of snakes. So we were up in Minocqua, northern Wisconsin, go 300 some odd miles that way straight on Route 39. So basically it stops. You've been up there? So we have, our relatives have a place up there. Yes, sir.
Wait, where you at?
My family.
Oh, your family.
All right. And we were in the backyard, just, it was a year ago last weekend over Columbus Day weekend. We usually go up there. And we were in the backyard just throwing a baseball or throwing a football or whatever. And then all of a sudden, one of the kids went to go pick up the football off the ground, and there was a snake right over him. Of course, my oldest son is just freaked out by it. So Moose, because Moose is fearless, walks right up to it. What's that? Oh, because he's huge. So, and he's fearless. So Moose sees the snake, he walks right up over it, just picks it up and goes, "What? It's just a snake." And he's walking around, it's like a little 2-foot snake. It was just a little garter snake. It was pretty funny. So he's walking around, and Connor's just like, he's screaming bloody murder, like somebody wants to come after with a chainsaw. My wife is freaking out. I'm sitting here laughing, trying to take a picture of Moose walking around going, ah. It's like teasing his older brother with a snake, so I thought it was really funny. But yeah, anyway, counterexample, anything that disproves a given statement. When we used counterexamples, we used them in here with all that P and Q junk. I did. Okay. We did conditional, converse, inverse, contrapositive. So we took things that were statements, and then we turned them into an if-then statement. Okay. And that's where it comes from. That's the idea of this. So we talked about, remember we did this thing called a conditional. And I think I finally have an example where everything's false. I'm going to start, I'm sorry, I had to take a sip of coffee. I'm going to start with the idea of just the statement, and then we'll turn it into the conditional if-thens and go from there. So the basic statement I'm going to use is this. All motorcyclists wear helmets. Now, there's no if-then here, is there? It's just all motorcyclists wear helmets. Let's turn that into the conditional, which is the if-then statement. If I turn this into a P implies Q, which is conditional, What do you have to put into that statement? If you are a motorcyclist, then you wear a helmet. True or false? False. Okay. I'm going to abbreviate motorcyclist, which just that's not to write it all out. Yes, ma'am. The P and Qs? Yeah. Well, which one's which? You know, it's remember it goes conditional, converse, inverse, contrast. Okay. If you're a motorcyclist, then you wear a helmet. Is that true or false? False. Not everybody that rides a motorcycle wears a helmet, but they should. You're right. What's that? Yeah, remember, whenever we wrote these things out, if I have you guys write these out like we did in our homework and stuff, I would ask you to say if they were true or false. If it was true, you didn't have to do anything, but if it was false, you just had to come up with a counterexample. And you're right, in Illinois, there is no helmet law. But if you go to, I'd say about maybe 20 years ago, 15 years ago, there was helmet law in Wisconsin. And when I used to, back then when we'd go riding, I always wear a helmet, so it didn't bother me. But when some of my friends, when we would get over into Wisconsin, they'd have to stop, take a helmet out of a backpack and put it on and keep going. Like, why wouldn't you just wear the thing the whole time? It blew my mind that you don't want to wear a helmet. Seriously, it's what they do. It's annoying. But in California, I believe Florida still, you have to have, those are, I think the only ones I can think about that have a helmet law. But their helmet laws are like, if you have a helmet that's just plastic and DOT approved, that's really all you have to have. Where it just has a sticker on it says DOT. This isn't going to do anything for you, but you're just playing the game by putting a helmet on. That's all you're doing with that. So, but yeah, that's how things work. Anyway, so there's that one. After this, then you had your flip it. That was your converse. Right. You say it backwards. Q implies P. If you wear a helmet, right, that's a counterexample. You could be a bicyclist, you could be a football player, a baseball player, a snowmobiler, you could be like skiing, you could be anything, Right, roller, I like that one, roller derby. Yeah, I heard that one earlier. I haven't heard roller derby yet, that's funny, I like that. A what? A fencer, yes, you could be a foilist. No, that's what their stories about. They're called foils. That's an 80 thing. I know that. My dad was one. Yeah, he gets to be an astronaut. All right. So far we're 2 false, aren't we? Okay. Go to the next one. The next one was the inverse. Inverse was not P implies not Q. So you go back to the original. If you are not a motorcyclist, then you do not wear a helmet. That's also false because, again, you could be a fencer. I like that one. It doesn't say tinfoil helmet, it just says helmet. Okay.
You could be a horseback rider.
Again, guys, I know it can get kind of absurd as you start figuring out all these different counterexamples, but each one that you're saying is true. You're the horseback rider, a construction worker, an astronaut. I don't know if that's, you can be astro person. How about this? Space explorer. Save me! What's up? This means not. Remember this, sorry, it's not drawn nicely. This was not P implies not Q. We wrote it like that because the book uses the squiggle. I think when I first did it, I did this. I'm going to switch it back to keep it to that stuff because that's what the textbook does. What's that? Oh. This just means not. Okay? These, guys, this single squiggle just means not. Yeah, not P, not Q, it's negation. This also stands for the same thing, just the older textbook did that. That's why I just keep using that once I'm used to the old stuff. And then the last one was the contrapositive. Not Q implies not P. If you don't wear a helmet, then you're not a motorcyclist. And again, people that are motorcyclists don't wear helmets all the time. So see how we have all four of them, could be false. I didn't even think of that one, but yeah, there you go. Yep. Again, not all motorcyclists wear helmets. Okay. All right. So, excuse me. As you go through these, the idea is remembering the sequencing: conditional, converse, inverse, contrapositive. Okay. PQ, QP, not P, not Q, not Q, not P. Just remembering how the patterning works. Remembering that as you go through it, if it is true, you don't have to worry about it. If it is false, you just give your counterexample. This was a good one that shows all false. All right, so it is possible. I don't know why I didn't think of that one before. Okay, that's space person. I like that. Back to 2.4 then. 2.4 was the law of detachment, and then the law of syllogism. The law of syllogism stuff. So again, I'm just going to go back to a couple of examples of what that looked like. And if you recall, it was really, really easy. It was just identifying which of the patterns were occurring, and then could you come up with a valid conclusion given a statement. For example, if I go to the law of detachment, exactly, that's exactly what it stands for. And I think the example we used was if Moose eats a pizza, yeah. If Moose eats a pizza, then he has a Sprite. That was the if-then statement that was given. Next part was Moose ate a pizza. Yep. So this would be the kind of sentence structure that you'd be given. If Moose eats a pizza, then he has a Sprite. Moose ate a, bless you. Moose ate a pizza. Is there a valid conclusion that you can come up with there? He had a Sprite. So yes, this works because of the law of detachment. Your statement would have been Moose had a Sprite. Okay, that's the idea behind detachment. Remember how I described it as being kind of choppy? Moose ate a pizza. If Moose eats a pizza, then he has a Sprite. Moose ate a pizza. He has a Sprite. And just like you were saying, if you detach the if-then statements, they become two separate sentences. I can speak. I'm SFT. That's how it works. The whole. It's a Homer Simpson. I haven't watched it in 15 years, but way back in my day, it was really good. You know, that's the longest running TV show in history. I haven't heard that. I wouldn't be surprised. It's been on. I think it's been. I wanted to say it started about 89, 88, somewhere in that neighborhood. There used to be a little skit, like going in and out of commercials for there's a show called the Tracy Ullman Show. It's like a variety TV show. It's kind of like a Saturday Night Live, like half hour long. So anyway, the other one was the law of syllogism. Yeah, and the one that we did with this one was, I think we did what Tom was taller than Bob. Yeah. Nice. You had a sentence like this, or an instance. Yeah. Tom is taller than Bob. Bob is taller than Bill. Therefore, what conclusion can you come up with? Tom is taller than Bob, or Bill, excuse me. And what we said all the time with this one was that there was always this cross-referencing here. The repeated part, what you end with, you start with the second. And what you end with, you start with the second. That's where this comes from. Okay? It was that law, we called it the transitive property. And we'll do more of that stuff via transitive next week when we get into congruency segments and congruency of angles. And that's how we kind of continually build working with these statements and stuff, okay? 2.5 then, all we did in there, in 2.5, this was just algebra proofs. Yeah, and you guys kind of flew right through that. There wasn't really much craziness there, aside from skipping steps. Yes, sir?
So, for the algebra proof on the quiz, do we need to know like all the reasoning?
You have to have your reason bank. I haven't told you that. So, for example, if I give you guys a statement of reason, or if I say, solve the following equation, show all your steps, that kind of stuff. Yeah, so let's say your equation was this, 2, and that was the equation that I gave you, you wrote it down, you wrote this as your given. From there, you went through the process of doing all the steps. What would you do first here? Could you, or could you just, does it matter which one you did first? It doesn't matter, no. Most people in this one, they see distributive property, and they just use that first. So what you guys have been doing is you would just show that you're doing that, and you'd write 2x minus 2 minus 4 is 16, and your reason was distro prop. Now what would you do? Simplify. Very good. Combine like terms. We would call that simplify. So I would rewrite it as 2x minus 6 is 16, and write simplify. If you wrote combine like terms, is that wrong? No. It simplifies. I think it's just easier to remember that. And now you're back to a two-step equation. Add prof equal. Very good. Is it okay to have more than one simplify? Again, you guys flew through those. Those were really simple for you. There was not much craziness, okay, aside from skipping a step here or there, but otherwise you guys were doing just fine. But it doesn't matter, you still had to show all your steps, and that's how that came about. Okay. I've been saying this for a while now. Next week, we start Monday and Tuesday. We're going to do algebra proofs, but with segments, which means we'll have segment addition. We'll have midpoints, bisectors. We'll have, and then on Wednesday and Thursday, we'll do angles, which means we'll have angle addition. We'll have angle bisectors. And it's all going to stem from using properties of midpoints, angle bisectors, segment bisectors, as well as the algebra. So Monday, we'll do a couple of progressions and then start working through them ever so slowly to start filling out proofs via segments and stuff. Usually what I do with that, after we get through those two, sometimes we have another really short quiz on just segments and angles. It's usually like 3 proofs, and it's usually not a big deal. Then we can start triangles afterwards. Okay? Not until we get to triangles. So normally what I do with chapter 2 stuff, since it's such like a hodgepodge of meandering back and forth between a lot of things, is that I normally do just 2 quizzes with this stuff. And then I go into 4 because you have to know how to do all this stuff well to get to 4. So algebra stuff, like I said, you guys are fine. I'm not really too concerned about that. And then the last thing was in 4.1, what we did on Tuesday, and that was your congruency statements. So when you're dealing with the idea of the congruency statement, it dealt with the fact that you were working with triangle ABC is congruent to triangle XYZ. And you might have to list out what parts are congruent to what parts. You might have to draw a diagram. You might have to fill in the blank like that number, what was it, number 8? Number 8? Number 5. I'm sorry, number 5 you were asking about. Number 5 where you had to figure out the correspondence to figure out what the angle measure was. Things like that. You could, I don't remember that off the top of my head. You could have something like this, where you have ABC and XYZ. If this is 52, Y is 83, and then I want to figure out what angle B is. Okay, what if I wanted, instead of angle B, what if I want to figure out what angle C was? See how that works? You're following the correspondence around to see how the letters match up to know which triangle you can move that 83 or that 52 back and forth into. Now, it could be just find the measure of angle C, or it could say, let's say angle C is 3x minus 4. Then you have an algebra problem to work with. Again, it still stems from the idea of working with the correspondence to get to it. I don't think that that's been too big of an issue, to be honest with you. I think you guys have done fairly well with that, just in the course of that first day of it, because we really haven't gotten too fancy with it yet. It builds, and you don't want to, get too difficult right off the bat, because then you guys are really going to hate math more than you probably already do. No. The only thing that I would do out of something like 4.1 is list correspondence, or which of these things works, which one doesn't work. I'm not going to make you do a 2-column proof. The only 2-column proof you have to do will be algebra again. Yeah, we're not good enough. I'm not saying that you guys aren't good enough at doing stuff. We haven't learned enough yet to do it. So by the end of next week, yeah, I can say, hey, here's a given statement that's a proof statement. You'll be able to do it. I have the pacing that we're going through right now, I have no doubt you'll be able to do that next week. Other than that, that's really kind of what we did. I know you guys were asking, like, what am I looking at as far as problem-wise are concerned? I went through the book and I found a couple of sections of problems that I will collect tomorrow. What's that? No, but you guys can use the reasoning bank and the progression sheet. That's the whole point of doing those. What's that? So what I want you guys to do on page 130, I want you to do numbers 12 through 19, and then 27 through 30. Then on page 274, I want you to do numbers 5 through 14. Now, I know that 5 through 14 looks like a lot of problems, but it's 2 diagrams. It's just a bunch of questions off of 2 different diagrams. Okay, diagrams. Don't forget, I could ask you to look at a diagram and tell me if something's true or false. Like we were talking about, what inferences can you make? You you tell if something's been bisected? Is there ways to tell you about right angles? Can you tell if things are parallel? Little things like that by just looking at markings and whatnot. Take Chromebooks out, screenshot it now that way you don't lose it in case you forget the internet. I got a textbook up here if you want to take a picture of the problems, by all means do that as well. That way you have stuff to do and you probably knock this out here rather quickly. There's not much here. Don't forget reason banks and that progression sheet. If you've added stuff to it, make sure you take a picture of it. You can come up and do it now. It's no big deal. I don't mind. So yeah, all right. Bless you. I appreciate you waiting, buddy. I knew what you were about to do, so it didn't bother me to wander around. But I appreciate it.